everyone and welcome back. This is Esther here, and today we are going to be starting with introduction part 2 to exercise 2.1. Sorry I haven't been uploading in quite a while now because I had a lot of schoolwork, assignments, projects, homework, blah blah. I had a lot of work and I couldn't find time to record. I did record previously, but I couldn't upload it as well. But henceforth, I'll at least try my best to upload a video per week. So I won't disappoint you at least by doing that. So in this session, we are going to be covering these topics as you can see here: types of terms, zero polynomial, degree of a polynomial, degree of a zero polynomial, degree of a constant polynomial, types of polynomials, and the standard form of a polynomial. Okay, in the previous video, we had introduction part 1 to this chapter, in which we covered various topics and I brushed up the basics of algebra and algebraic expressions like constant, variables, terms, coefficients, and what is a polynomial, how do we identify whether a given expression is a polynomial or not. And I think this is all we did, or maybe there are 2-3 concepts which we further did as well. So let's start with this session without further ado. So firstly, we will start with types of terms. What is this types of terms? What do I mean by that? See, types of terms. So we have something called as constant term. What does constant term mean? By the two words constant term itself, we can identify that there is no variable in the term. Okay, so constant term is the first type. Just a second. Yeah, so constant term, by the name itself we can see that there is only a constant. There's not going to be any variable. That's why we call it a constant term. No variable in a term. In a term, the word highlighted here is called, is nothing but term. It doesn't mean that in the whole expression there will be only a constant term. No, there will be variables, terms having variables as well, but in one term where there are only constants, that is called as a constant term. Let's take an example for this. Example. So firstly we can take x square plus x plus 2. What is the constant term here? This is nothing but 2. Right, look at this term. You know what is a term? Term is basically separated or identified by plus or minus sign. So how many terms are there in this expression? 3 terms, and this term is nothing but a constant term. Constant term, because it doesn't have any numbers in it. That's why we have such a name for it. Okay, so then the next type of term is, I think this and all, maybe you've done it in the previous class, or maybe actually you have done it. Yeah, just it's like a recap, I would say. Like and unlike terms. Like and unlike terms, of course we know this, definitely, I'm sure. So in proper words, terms having same variables. Okay, wait 1 minute, just a sec. I'm not going to write it like this. Okay, first we will discuss one by one. First we will do like terms. So this is nothing but terms having same variables and powers. Like terms are those terms which have same variables and powers. Such terms are called as like terms. Okay, so for example, we can take 2x square plus 4x square plus 3x. Now look here, look at 2x square and 4x square. Are they having same variables? X here also we have x. What about the power? Here we have 2 and here also we have 2. So what can I say? These two are nothing but what? Like terms. Okay, these two are nothing but like terms. So what will we further do next? Next we will add it. So we will add the coefficient of both the terms. So 6x square plus 3x will be the final answer, but The point here is these two are like terms. Why? You need to always check whether it has the same variable and the same power. That is the condition for a term to be called as a like term. What about unlike terms? Unlike terms, of course, they do not have like variables and like powers. So in other words, unlike variables and powers. Unlike variables and powers. Many polynomials are of this form, right? I'm sure you all would have noticed that. And many polynomials have such unlike terms. Okay, so example for this is what? Let's take 2x squared plus 2x cube. Or a very good example here itself, this one. This itself is an example of unlike term. Why? Because here you can see that there is a like variable, but there is not a like powers. Therefore, it is unlike. Here you can see, for a term to be called as like term, it must satisfy both the conditions. If it has like variables and like powers only, it is called as what? Like terms. But if it has like variables and unlike powers, we cannot say that it is a like term. Suppose it has unlike variables and like powers, still also we can say that those are what? Unlike terms. They cannot be called as like terms. I hope I'm not confusing you. In simple words, if a term has the same variables and same powers, we can say if it is unlike, say it is like, okay. But if there is unlike variables and unlike the powers here, so then we can say that it is an unlike term. So a very good example is this one. I hope it is clear to you. This is the third one. Fourth one is nothing but yeah. So the fourth one actually is not a fourth one. That's it. Okay. So these are the types of terms. Simple, right? I'm sure it is pretty easy for you. Now, what was the second content we had? Second topic, zero polynomial. So let's go now to zero polynomial. Zero polynomial. What is a zero polynomial? The number 0 itself is nothing but the zero polynomial. Yeah, by the word itself, by the word zero polynomial itself, we can say that the number 0 itself is known as the zero polynomial. So keep in mind, zero polynomial is nothing but 0. Such a hard concept. I'm sure you all are struggling to remember this, right? Just kidding, okay? I'm sure it's so easy for all of you so far. Okay, so next, it was quite an easy one. Next is degree of a polynomial. Very important concept and not a very hard concept as well. Degree of a polynomial. So what does this degree of a polynomial exactly mean? So if I say degree of a polynomial in one variable, okay, we're studying only about one variable now. It is the sum of the powers of the variables in each term which is taken up, and the highest sum so obtained will be the degree of the polynomial. Quite a huge definition, right? But what does it exactly mean? I will write it down for you as well. Okay. Okay, so now I've written down the definition here on the screen for you. I've actually typed it out. So, what is the definition? It is the sum of the powers of the variables in each term which is taken up, and the highest sum so obtained will be the degree of that polynomial. What does this statement actually mean? Let's see that. So, it is the sum of the powers of the variable. Sum of the powers, right? This is the power of a variable. Here, this is 3 here. Here it is 2. Here it is 2. It is the sum of all these powers of the variables in each term Okay, so this is one term, then this whole thing is one term, this is one term, this is one term, this is one term. So, and the highest sum so obtained will be the degree of the polynomial. So what we're doing in each term, we are going to be adding up all the powers of the variables in each term. And the highest sum will be what? The degree of the polynomial. Fine. So here if you see, we have x variable which has power 3. So here I will say that the power is 3. What about here? Now you see it is the sum of the powers. So that means you have to add. So what is 2 plus 2? 2 plus 2 is nothing but 4. Okay. Here it is 1. Here it is 1. We know that, right? And this is nothing but 1 plus 1, which is 2. Then here we have 1. So that means it will be 1. What about this? Now look here. 8x if I'm taking. Here also it will be 1. Now let's see there is another term 4. What about this? What will I do for this power? Remember that always constant terms like these have an invisible x raised to 0. What is this invisible x raised to 0? Let me tell you. So 4x raised to 0. Now you would have learned last year in chapter 12, that is I think laws of exponents, that a raised to 0 or maybe x raised to 0 is equal to 1. Anything raised to the power of 0 is equal to 1. So when I apply this law here, 4 into x raised to the power of 0 is equal to 1. So therefore, I can say that 4 into 1 is 4, which gives me nothing but 4 again. So usually we won't like write this like in the question and all, we won't get such thing. But for your understanding, remember always that no matter what constant term is there, there is always an x raised to the power of 0. Why are we getting this here? This actually doesn't make any difference to this term. When we raise it to the power 0, we will get 1. 4 into 1 is 4. But when situations like when we have to find out the degree of the polynomial, yes, we have to write it like this and then extract the degree. So here degree will be 0 because here again we have the degree as 0. So now you look here, we have found out the sum of the powers in each term. Now what is the highest sum? We found that it is 4, right? So what is the degree here? 4. You understood? You have to get the sum of the powers in each term and check which is having the highest sum of the powers. And that will be the degree of that polynomial. It's clear, right? Easy. I hope you understood. Let's see another one. Look here. Xy plus y cube plus x square y square. Same law here. Now look here, x raised to 1, y raised to 1. 1 plus 1 will give you nothing but 2. And here, y cube, so 3 is the power. Here, 2 plus 2 will give you nothing but 4. So what is the degree? Again, it is 4 here. Right, so you always have to find out the sum of the powers. Let's take another example. 4x square y cube minus 5x square y square plus 7 minus 2x raised to 4. Now look here. This will have the sum as what? 2 plus 3 which is 5. Here 2 plus 2 which is 4. Here this will be 0 according to what we did, here this law. Okay, according to this law, this will be 0. And here this will be what? 4. Now if I add root here, root 2, it won't make any difference. Why? Because we're looking only at the variables. Remember, it is just sum of the powers of the variables, not the constants of the variables. So here 5404. So what is the highest degree here or the highest sum? Of course, it is the 5. So therefore the degree is 5 because 3 plus 2 is equal to 5. Clear? I hope it is clear. This is a very easy thing, okay? Nothing hard. So nextly, let's move on to the next concept or the next topic here, which is nothing but degree of a degree of a zero polynomial. Yes. So degree of a zero polynomial. degree of a zero polynomial. What is the degree of a zero polynomial? If there's a question that comes to you in the exam paper, like what is the degree of a zero polynomial? We say that in such cases, the degree of a zero polynomial is not defined. You heard me right. Yes, it is not defined. Degree of a zero polynomial is not defined. I took this concept separately because it's a very important one. You could get a question. What about the degree of a constant polynomial? Degree of a constant polynomial. What about this? This is nothing but 0. Okay, degree of a constant polynomial is 0. What is this? Wait, what is this constant polynomial? That means there's only a constant there, right? So therefore, here in this case, we saw for 4, it was nothing but x raised to the power of 0, which is nothing but 4 into 1, which is nothing but 4. So therefore, the degree of a constant polynomial is nothing but 0. Remember, degree of a constant polynomial is equal to 0. I hope it was clear so far. Okay. So I think we're coming towards the very end of this session. I think few more topics to go and we'll be done. Okay. I hope it's interesting so far. Now the next one is types of polynomials. What are the types of polynomials? Let's check out. Types of polynomials. We saw types of terms. Now we are saying types of polynomials. Now we classify polynomials on two bases. On the basis of number of terms and the degree. On two bases we classify terms. We classify, sorry, not terms, classify polynomials. So let's check out now one by one. So just want to take a different color. Yeah. So let's first see the number of terms. On the basis of number of terms, we classify polynomials into monomials, binomials, and trinomials. Okay, I'm sure you all of you have heard of this in your previous class. I mean, in 8th standard, 7th standard also. I'm sure you would have learned this, right? I hope you remember. Okay, so this is a very easy one. So monomial is nothing but an expression containing one term. Binomial is an expression containing two terms. And a trinomial is an expression containing three terms. So this is having one term in an expression, here two terms and three terms. Example, of course, we always explain with an example so that the picture is clear for you. So first, for monomials, we will take x. X itself is one expression and this only one term is there, or let me take x square itself. Yeah, so here this is a monomial expression. What about binomials? Two terms, x plus y, this is a binomial. Z plus 2, this is also a binomial, and etc. We can keep going on and on. What about trinomials? We can take x plus y plus z. Okay, or we can take z plus 2x plus 5. This is also another trinomial expression. Clear? These are the types of polynomials on the basis of number of terms. What about the types of polynomials on the basis of degree? This is a new concept to you, on the basis of degree. This number of terms you would have learned last year, definitely, right? So now, what about number of terms? We finished that. Now, based on degree, we classify polynomials firstly into constant polynomial. Constant polynomial, and then we have linear, quadratic, linear, quadratic, and biquadratic. Sorry, cubic, and then biquadratic. Yeah. Cubic, and then we have biquadratic. I think biquadratic spelling is wrong. I'm so sorry. I'm making a mistake. Okay, so I guess this is the spelling of biquadratic. So in a constant polynomial, we have the degree as 0. Degree is 0. Here in linear polynomial, we have degree as 1. Degree is 1. Here it is 2 degree. Okay, degree is 2. And here in cubic, degree is 3. And here in biquadratic, degree is 4. I hope it is quite clear to all. So now let's further see this with an example. So, okay. So, yeah. Example, we will take for a constant polynomial, of course, we can take 5, root 2, half, all of this, etc. For linear example, we can take what a x plus b, where a is not equal to 0, or we can take, okay, wait, this might be a little confusing for you, ax plus b. So we will take here, let's say 2x plus 1. Here, this is a very simple one. X is having degree, the power 1, and 1 is having x raised to 0. So, of course, degree is 1. So, such an expression is called as linear polynomial. And then we have examples for quadratic polynomial where degree is 2. We can take ax square plus bx. Now here we are having power 2, okay, for x. Another example, let's say 2x square plus y. Here again the quadratic, what do you say, it is a quadratic polynomial, okay, since the degree is 2. Now for cubic, we can take ax cube plus bx square plus cx plus d. We're looking only at x, okay, and a is not equal to 0. So here again you can see the degree is 3, right? So I'll just highlight the degree for you, 2, and here 1, and here this will be 0, right? Then coming back, we have for biquadratic, ax raised to 4 plus bx cube plus cx square plus dx, okay, plus dx plus e. Okay, so here again we can see that the degree is nothing but 4. So yeah, guys, this is nothing but the types of polynomial based on degree. Let's see that once more. Constant polynomial has degree 0, linear polynomial has degree 1, and then quadratic has just degree 2, cubic has degree 3, and biquadratic has degree 4. Fine. So these are the types of polynomials. Next, what is our next last thing? So we have covered all of this, right? Look how many concepts you've understood. Pat yourself, pat your back if you have understood it. If you didn't understand, just rewind the tape and go back again to where I've explained it and try to understand. If you didn't understand it, let me know in the comment section. I'll try to help you out. So lastly, we are going to understand the standard form of a polynomial. What is the standard form of a polynomial? Let's check out on that. Now, if I have an expression 2x squared plus 1 plus 4x, you tell me that is this a polynomial? Yes, it is a polynomial. Why? Because all the powers are positive integral powers, right? So, yeah, that is nothing but a polynomial. But it is not in its standard form. It is in some form, but that is not the correct form of a polynomial. Usually, we will write a polynomial in either the ascending or descending order of the degree. So, did you understand what is that? Now, what is the degree here? We saw that degree is 2 here. So, we need to write this in either ascending. Either we need to write this as, we have to write this as 1 plus 4x plus 2x squared, or 2x squared plus 4x plus 1. You see here what is happening? We are ascending, ascending. But here, if you see, we are descending. Oh, sorry, the arrow is in the wrong direction. We are descending to the smallest power. We are descending, right? So usually we write it in the descending form if you see in most of the expressions. And sometimes when you are dividing polynomials, we'll go to that later, we'll study about that later. But when you divide a polynomial, first we need to check whether the polynomial is in standard form or not. If it's not in standard form, you'll get your answer wrong, and it's wrong to divide it in that way anyways. So you need to know what is the standard form. So the standard form of a polynomial is either the ascending or descending order of the degree. Okay. And we know that what is the degree of the polynomial? That is the highest power of the variables in each term of an expression. So yeah, this is nothing but the standard form of the polynomial. And if an expression is said to be a polynomial, we will write this as P of x is equal to this. How do we say this? We don't say this as P into x. We say this as P of x. Why we say P of x? Because this is a polynomial. So the polynomial is equal to 2x square plus, no, this is not the standard form anyways. So we will say that this is the polynomial actually. This is the polynomial. 2x square plus 4x plus 1. So P of x is equal to this. Okay. So I hope it was clear. This is the standard form of a polynomial. And that's it, guys. We have come to the end of this session. Yeah. So I hope you found it fun-filled and easy. It is covering a lot of concepts. I agree. We did a lot of things today. I hope you made notes of it, or else you can again go through it and make notes. And make sure to read it along with the notes that your teacher gives in school. Okay. So like most of the teachers, like I actually pity them. They would be running like a metro train because they have to cover so much of portion. We cannot blame that, saying that mom is going so fast and she's running like a metro train. But what can she do? She has to cover the syllabus. So that's why we're doing such videos where we go through each and every concept clearly. And I want you to study all of these concepts along with the notes that your teacher gives. So when you understand the explanation of each of the content, then when you compare it with your notes given by the teacher, things will start to make sense to you. Okay. So I hope you found this session helpful. In the next session, we will meet back again to start with exercise 2.1. So till then, take care of yourself, stay safe during the pandemic. God bless you. Bye for now.